Hey everyone, and welcome back to this class, Natural Language Processing in Python. In this lecture, we will continue looking at our code to implement a cipher decryption algorithm. This lecture will focus on creating functionality to encode and decode a message. The first thing we need, obviously, is an actual message. This message is a paragraph I took from another classic book, The Adventures of Sherlock Holmes. So below this, I've commented out a few more lines, which are other paragraphs from the same book. The results we get at the end will depend on what the original message was, so you can try adding these to the message if you like, to see what kind of results you get, and what kind of tuning you have to do, if any, to get it to work. For example, you might change the size of the DNA pool, the number of children per parent, or the number of epochs. Next, we have a function to encode a message. It takes as input a raw message, such as the above, and returns ciphertext representing that message using the substitution cipher we defined at the start of the script. Inside the function, the first thing we do is lowercase all the letters. This is because our mapping only contains lowercase letters. Next, we use our regex from earlier to replace all non-alpha characters with a space. This is because we do not have any mappings for non-alpha characters. Another option would be to simply leave those characters as is, although that would take some additional work. Next, we enter a loop to build up the coded message. We start by initializing the coded message as an empty list. We'll be converting and storing each character one at a time. Inside the loop, we'll initialize coded ch to be just ch. This is because if the character is a non-alphabetical character, then there is no mapping for it. Next, we check if ch is in our dictionary true mapping. If it is, we index true mapping by ch to get the cipher character. We assign this to coded ch. Next, we append coded ch to the coded message. Finally, when we've completed the loop, we join each character in coded message to create a final string. Next, outside the function, we use our encode message function to encode the original message, and we'll call this variable encoded message. Next, we have a function to decode a message. This takes in two arguments, a ciphertext message and a word map. This function largely works the same as the encode function. It just maps each character in the input to a different character according to the word map. It's just that this word map is an argument to the function, whereas for encoding, the word map was the true mapping we defined earlier. So to start, we create an empty list called decoded message. Then we loop through each character in the message. Inside the loop, we assign ch to decoded ch. Remember, this might be a non-alpha character, in which case we would not do anything to it. Next, we check if ch is in our word map. If it is, we index the word map using ch and assign the result to decoded ch. Then we append decoded ch to the variable decoded message. Finally, we return the decoded message joined into a single string.